What do I have to know how to solve when a is not equal to 1? Well, when we're looking at an equation, when we have x squared plus bx plus c, this is a quadratic when a is equal to 1. Obviously, you can see there's not an a, right? And one of the main things that I talked about, when we factor this, we factor this with these two values of p and q, x plus p times x plus q, where p times q equals c, and p plus q equals b. Now remember where our p and q come from? P and q come from the factors of c. Now what's important about when a is not equal to 1, now we're going to have a value for a. And what's really, really important about this is now we have to find our factors, because if you notice when I multiply this, right, when I take this, when I take these two binomials and I multiply them, I know that x times x is going to give you x squared, right? But the problem is if I factor, and what a lot of students still do is they do the same technique. They don't care if it's x squared or if it's ax squared. They say, oh, well, I'm just going to find the values of c, the two values that multiply to give me c, but then add to give me b. And those two values are p and q, and then I factor it like this. So they kind of like totally forget about the a, and they say that those two values have to look like this. All right? But that's the very big common mistake, because x times x is not going to give us ax squared. What we need to make sure that we're aware of when doing a problem when a, or I can leave that in there. What we need to make sure that we're aware of is that we need to multiply x times x to give us this ax squared. Therefore, we need to have values in front of these x's. Now, these values, I can give them another variable to say I could call them n and m, all right? But I think, when looking at this mentally, at the end of this course, that might make a little bit more sense. But at the beginning of the course, you might still be like, oh my God, I'm just seeing all these letters. Like, what the heck is this guy talking about? So the basic thing that I really want you to understand is when you have, or what you need to know for this course, when you have a value in front of your quadratic term, in this case, what we call their a, and again, that represents any number that's not 1, we can't go back through our general factoring technique like we did over here, where we make the nice x. Now we can, and that's one of the methods that I show you in this course, is still applying that method, but just a little bit of twist. We also go through a couple other methods that I reach you that I think might help you out or might make a little bit more sense. But the main important thing when you're doing this is that now, instead of finding the values, so over here, we had c and b. What two factors multiply to give you c, add to give you b? And we call those two factors p and q. Now what we're going to be doing is finding the factors for ac that multiply to give you a times c, but then add to give you b. And again, this is just one technique. But it's very important because a lot of students really understand this and they really get this, but then they kind of get set up on how to change over when you have that a. So the difference in these two techniques is now we're going to multiply a times our c. So we're now going to find the factors of a times c, and those factors need to add to b. Then what we'll do is we'll do some factoring by grouping, or also use the box method to help us factor that out, and so on. But the main thing that you need to know is there's a difference when we have an a and when we have an a that's equal to 1. And the main difference is you can't have these two factors multiply to give you x squared. Now we have to have some values n and b that are going to multiply to give us a, where I can say n times m is going to equal our coefficient a. So to do that, there's a couple techniques I'll go over. We'll learn how to do them in our head and also learn how to do them step by step. But that's the main important thing I want you to know when solving. And as far as the solving part, we're still going to apply, once we get it factored, we still apply the zero product property and then solve. And then the other thing that you need to know is, here when we use the zero product property, it's a quick inverse operation. But now we're going to have a two-step equation to solve once we get it to the zero product property. But anyways, guys, I don't want to give away too much away. I just want to kind of give you a little bit of a lead-in of what to expect and what you kind of should know going into this. And we will continue on with some more examples. Thanks.